Okay, let's take a look at the first problem. The first problem is asking us to find V Thevenin, R Thevenin, and I Norton from A to B. So, um, what does this mean for us here? So, if we did points A to B, um, here we would do, since these are open here, so you gotta do it like this. There we go. So now we're saying that if this imaginary wire is here, uh, to find R Thev, what we're going to do is look for any dependent sources. No, so we're good. Step 2, we'll zero out sources. So we'll take all batteries, we'll turn them into just plain old wires. We'll take all current sources, turn them into clipped out bits. Okay, so if we do that over here, okay, where this will be 2, 1, 1, and then 1. Okay, so now that we've redrawn this, we're going to work that way to VOC. This is also VOC up here. But now that we've done this, now we will find our Thev. All right. So if we find our Thev, we're going to look at our bottom circuit here, and we've done enough combinations in this course so far that I'm going to write out the parallel and series combinations, trusting that you can do the calculations yourself. Okay, but what we'll do here is, or I'm not going to redraw it really. So first off, we see that these two are in series, so we'll call that series 1. And after we combine those two down, we'll see that those two branches are going to be in parallel. We'll call that parallel 1. And then afterwards, we'll see that these two will be in series. We'll call that series 2. All right. So if we go and do that off to the side here, so I'll do R parallel, or I'm sorry, we'll do series first. Our series 1 is equal to 1 plus 1, which is equal to 2. Our parallel 1, which is equal to 2 times 1 over 2 plus 1. So this will be 2/3. I'm sorry, that should be 2. That should be 2. 2 times 2 over 2 plus 2. So this will be 4 over 4, which will give us 1. Then our series 2 will be 1 plus 1, which will give us 2. And then finally, this is what we will end up with. Our series 1 plus minus VOC. Okay. That point's still A, and that point is still B. All right, so now that we have those, we have one resistor, so we find that R Thevenin is equal to 2 kiloohms. Okay, so that's the first one. The next one is going to be to jump back to the original circuit, so back to OG circuit. So this bad boy. And what we're going to do now is we're going to figure out what the parallel value is for our two branches here. So this branch and that branch. since these two are in parallel with each other. If we find the drop across R2 and R3, we find the drop across A and B. So it's going to clean that up a little bit. There we go. Okay, so now 5, find VThev. So from here, if we were to look at our original circuit that had that open terminal there, we can see that if we had a current leave here, travel this way, and then hit this point, it can't go down the open terminal, so it'll travel through this way, travel through this way, and travel through that way. So just creating a loop. So therefore, we effectively only have one loop. So we can do one of two things with our loop here. I'm going to do a voltage division, or you can find the current. It's up to you. But voltage division works for me. So voltage division. And what does that look like? It looks like this. I'll just call it big V. There we go. So V is equal to R2 plus R3, because it's the total drop, it's total resistance along that branch, divided by R2 plus R3 plus R4 times V of the source. And that will give us 2 plus 1 plus 1. So this will be 2 over 4 times 15, which will give us 7.5 volts, which is equal to V, which is equal to VOC, because they are in parallel with each other. Bam, bam. There's V Thevenin. All right, so we've got one of two options. We can either do the long, complicated way of dropping this wire here and then trying to figure out current division and do a lot more work than we need to, or we can just find I Norton by using V is equal to IR, rearranging, say I is equal to V over R, which in this case I Norton will be equal to V Thevenin over R Thevenin, which will be equal to 7.5 volts divided by 2 kiloohms, which I believe will come out to be 3.75 milliamps for I Norton. All right, and that's all we got to do. All right, I'll see you in the next problem.